Welcome to the second video in the Collab Ed Chemistry course. Today we're going to be talking about units and the SI unit system, that is the international system of measuring all things in science around the world. And yeah, let's get started. So, SI units. Alright. So there are 7 main SI units, and they each measure an important attribute of the universe around us. So let's get started. So the first one is the unit for mass, and we call that the kilogram, or kg. I'm absolutely sure most of you are already familiar with this, and this is used to measure the amount of stuff, the amount of substance in matter, or the amount of matter. We can say that as well. The next unit is for length and measuring distance, and that is the meter. The meter right there, and we represent that with an m, with a lowercase m. Also, yes, kilogram is a lowercase kg. The next unit is one for time, which is not as important in chemistry, but I still want to cover all of the SI units just because all of them are important at some point. So, third one is time, and we measure that obviously in seconds, which is represented by lowercase s. I apologize, that looks like a uppercase s, but just trust me when I say I meant to write lowercase s. The next unit is something not as covered as frequently, but it is the amount of electrical current, and we measure that in amps or amperes, and that's represented by a capital A. Up next is one that is considerably more important to chemistry, and that is temperature, or the speed of atoms. We call that Kelvin, represented by capital K. It's Kelvin, and it is, if you know Celsius and Fahrenheit, you know Fahrenheit is a completely different unit for temperature. We don't use it at all in science. Celsius is sometimes used in science, but it has the same size as a Kelvin unit, but Kelvin is an absolute scale. It starts all the way at 0. It starts all the way at 0 Kelvin is absolute 0, where there's absolutely no motion in atoms, and that's why we call Kelvin an absolute scale of temperature, and that's why it's not used as common in that's why it's not used commonly throughout the world. It's very specific to science. The next unit is very, very important to chemistry, perhaps the most important of all of these units, and that is the mole. And that, a lot of people get the mole confused with the kilogram, and I'm about to go in depth on the chemistry specific units in a second, but a mole is the measure of the count, or the amount of individual particles of a substance. So kg measures the amount of substance raw. Mole measures the amount of individual particles of said substance. And the final unit, which is not as widely known or widely used, especially in chemistry, is the candela, which measures luminosity, or the brightness or power of light, and that's represented by lowercase c, lowercase d. So in this video, I'm going to be covering the kilogram mainly, Kelvin, moles, and to a certain extent the meter. So let me go ahead and clear my screen right here. So let's start with kilograms. So kilograms, obviously we spell it like so, and kilograms means 1,000 grams, kilograms, and again we use that to measure the amount of stuff or substance that we have. And this will that's pretty much all you need to know for now. So clear that. And then up next we have the meter, which is distance, obviously. Pretty simple, straightforward. Kelvin, I already covered that as well. But mole is the mole is something that is pretty confusing at first, but it is extremely crucial for you to understand in chemistry. So let's talk about the mole. And the full spelling of mole is MOLE, and when you're referring to it as a symbol, you just take away the E. So the mole, we define it as 6.02 times 10 to the 23rd power. And we say 6.02 times 10 to the 23 amount of stuff. Excuse me, not stuff. Or we can say count or number of particles, or number of units. So why do we have such a random number, 6.02 times 10 to the 23? Well, the reason we have that is because we use it to simplify the count of atoms so that we can convert from grams to we can talk about substances in terms of grams, which doesn't always allow us to accurately convert things or process chemical reactions. For example, if you were talking about 4 grams of grapes versus 4 grams of watermelon, well, that would be a completely different comparison, right? Because watermelon, it's a much bigger fruit than a grape. And the thing is, 4 grams of grapes may be like two or 3 grapes, but 4 grams of watermelon is like just a tiny chunk of the huge fruit. So when we talk about moles, when we talk about grams, we mean the weight of these two fruit, but moles, it talks about the amount. So we can compare 4 moles of grapes to 4 moles of watermelon, because 4 moles of, we can say 4 moles of grapes, we can count that as 1, 2, 3, 4. Similarly, 4 moles of watermelons, we can count that as 1, 2, 3, 4. So it's 4 separate entities, essentially. And that's the key to understanding the mole. It's just a count. It is just like a dozen. A dozen means 12. Similarly, a mole means 6.02 times 10 to the 23. And in upcoming videos, after I explain more about atoms and the atomic mass unit, moles will make a lot more sense. So now I'm going to talk about unit conversions in chemistry. Let me clear up. There we go. So let's talk about the idea of a unit. So when you say 5 grams of, I don't know, let's say iron of Fe. Well, we call a gram a unit, right? And where does the word unit comes from? It comes from un. It comes from the Latin root for 1. So in a way, it's like we're saying 5 times 1 of Fe. So at this point, it's not as important for me to talk about iron anymore, so I'm just going to cut all of this out. So if we want to convert, say, grams to kilograms, well, we know that a kilogram is 1,000 times as much as a gram. So 5 grams times 1,000 is equal to, excuse me, let me just ignore what I wrote right there. But we know a kilogram, the one unit of kilogram is equal to 5,000 grams. And if we think about it in terms of this right here, 5 times 1, well, you would want to eliminate that grams, right? You would want to multiply all of this by something that takes away this g. Well, if you know what reciprocals are in math, you can multiply by something with grams on the bottom, right? And that means that it'll cancel out. But if we want to take it to kilograms, we're going to have to replace the gram right here with some other kind of unit, and in this case we want it to be kilogram. So that means kilogram is 1,000 times bigger than grams, meaning that it is for every 1 kilogram there is 1,000 grams. There are 1,000 grams. So that means we can write this as a ratio. So 1,000 grams down here and 1 kilogram up here. So if you think about units in terms of a 1 being multiplied by this other thing, it really simplifies what this idea of converting with fractions like this. It really simplifies what that means, because you're just getting this little g right here out of the numerator, this little g right here out of the numerator. And to do that, you have to put it on the denominator. But the thing is, you can't just multiply, but you can't just divide by 1, but because that's the same thing. So you have to make it a ratio of the unit that you are trying to get to the unit that you're trying to get rid of. And that's why when we do conversions, we always use fractions with the unit you're trying to eliminate on the bottom and the new unit that you want to produce from the top. And with that is today's video. It was just an explanation of the SI units and unit conversions, how we do that, and also a quick explanation of the mole, the meter, the Kelvin, and what was the other one? And kilograms, yes, of course, mass. And those are the 4 most important units to chemistry. And with that, I hope you took some value out of this, and I hope that you watch our next video in our Collab Ed chemistry series. Thank you for watching.